In this next example, we should recognize this is almost like a difference of two squares, like x squared minus 4 equals 0. But it's a p to the fourth. I might want to notice that if I make the substitution, u equals p squared, then u squared would be, so square both sides, you would get p to the fourth. If you make this substitution, then the equation becomes u squared minus 4 equals 0. And you can solve that, add 4 to both sides, you get u squared equals 4. Take the square root of both sides, you get u is plus or minus the square root of 4, which is 2. This is actually two equations, right? U equals 2 or u equals negative 2. Once you have that, let's go back to the substitution that we made. U equals p squared. You can substitute back into these two equations that you have. Instead of u, write down p squared. So now we're back to our original equation. And you can solve those. P squared equals 2, square root both sides. We get p equals plus or minus the square root of 2. Here, square root both sides. We'll get p equals plus or minus. Notice you have a square root of a negative. That'll come out as I root 2. So at the end of the day, we actually have 4 possible solutions. Plus or minus root 2, so that's positive root 2, negative root 2, and plus or minus I root 2. So I root 2 or negative I root 2. Something to notice is that we get 4 solutions, and the original exponent was 4. P to the fourth gives us 4 different solutions. Let's do another example. 5x to the negative 2 plus 4x to the negative 1 minus 1 equals 0. Notice I'm dealing with negative exponents here. So what I'll do is, first of all, notice it's in the standard form, and the variable factor here has an exponent of negative 2, which is twice this exponent. So I'll make the substitution. U is the variable part of the second term, so x to the negative 1. And if you square both sides, we'll verify that u squared is x to the negative 2, which is the variable part of the first term. So now if I make that substitution, 5u squared plus 4u minus 1 equals 0. Now you can use whatever method you like to solve this equation. I think I'll do the AC method because this looks kind of familiar. If you multiply these guys together, 5 times negative 1 is negative 5. So find two numbers that multiply to negative 5 and add to the middle term, which is 4. Those two numbers are positive 5 and negative 1. So I'd like to factor this. I'll factor it by grouping. If you wanted to, you could instead use the quadratic formula, but I thought that this factors nicely. 4u could be written as plus 5u minus 1u, and then minus 1. So I just rewrote that 4u as two separate terms. And then you can factor by grouping the first two together and the last two together. So here I can pull out a 5u, and what's left is u plus 1. And in the second set of two terms, I'll pull out a negative 1. So minus 1 times what's left is a positive u plus 1. So now notice that you have this u plus 1 that you can factor out of the whole expression. So u plus 1. What I have left from here is 5u. What I have from here is minus 1. So now I get my two factors. U plus 1 equals 0, or 5u minus 1 equals 0. So subtract 1 from both sides, you get u equals negative 1. Here I'll add 1 to both sides, so 5u equals 1. Divide both sides by 5, you get u equals 1/5. So here are my two solutions to this quadratic equation. Now I need to remember that original substitution I made. U is x to the negative 1. And I'll write down my two solutions. So u equals negative 1 and u equals 1/5. And now I'll replace u with x to the negative 1. And now you have to remember, what is x to the negative 1? That's just 1 over x, right? So if I write this as 1 over x equals negative 1, now you can just take the reciprocal of both sides, if you like, or even multiply by both sides by x, whatever you like to do to get rid of this x in the denominator. So I kind of like to just think of this as a fraction. Flip both sides. So this will be x equals 1 over negative 1, which is just negative 1. So that's my first answer. My second answer, again, x to the negative 1 is just 1 over x. So if 1 over x is equal to 1 over 5, take the reciprocal of both sides, you get x equals 5 over 1, or just 5. So I get my two solutions to the original equation. All right, let's do one more that involves both negative exponents and fraction exponents. So this one looks very strange. Notice it's in the standard form, 3x to the negative 1 minus 20x to the negative 1/2 plus 12 equals 0. So this middle term here, multiply the exponent by 2, you get this exponent here. So this is a quadratic-like equation. I'll make the substitution. U is x to the power negative 1/2, so the middle variable term. And verify that if you square both sides, you get x to the negative 1, which is the variable part of the first term. So this does work. So let's go ahead and make that substitution. 3x to the negative 1, that'll be my u squared, minus 20, x to the negative 1/2, that'll be u, plus 12 equals 0. All right, so now I have a quadratic equation. I don't really want to factor this guy, so I'll probably just use the quadratic formula here. Remember, we use the quadratic formula. A is 3, B will be negative 20, C will be 12, and I like to do the discriminant first. So b squared minus 4ac. I just like to do that calculation first. So that'll be negative 20 squared minus 4 times 3 times 12. Let's just pull out the calculator to do that. So negative 20 squared minus 4 times 3 times 12. We get 256. So now when I use that to plug it into the rest of the quadratic formula, u will be negative b, so positive 20, plus or minus square root of that calculation I just did, all over 2 times a. So this will be 20 plus or minus the square root of 256 is 16, all over 2 times 3, which is 6. All right, so this is actually two answers. U is 20 plus 16 over 6, or U is 20 minus 16 over 6. So this becomes 20, that's 36 divided by 6 is 6, or 20 minus 16, that's 4 divided by 6. 4 over 6 is the same as 2/3. So I get my two answers, 6 or 2/3. Now remember that these are two solutions to this quadratic equation, so we have to resubstitute. So I'll write that original substitution up here, u to the negative 1/2. Write my two answers, u equals 6, or u is 2/3. And now let's resubstitute. U to the, oops, I forgot to write x. U is x to the negative 1/2. Okay. So u is x to the negative 1/2, so I'll replace u with x to the negative 1/2. x to the negative 1/2 equals 2/3. Okay, now I have to know what x to the negative 1/2 means. That's 1 over x to the 1/2, right? Okay, so let's go ahead and solve this. You can multiply both sides by x to the 1/2 if you like to get this out of the denominator. So this will be 1 equals 6x to the 1/2. Divide both sides by 6, you'll get 1/6 equals x to the 1/2. And to get rid of that exponent of a 1/2, I'll square both sides. Because it's like the square root, right? So this will be 1 over 36 equals x. So that is one answer. The other answer I get by doing 1 over x to the 1/2 equals 2/3. We can cross multiply if you like. So multiply both sides by 3, multiply both sides by x to the 1/2. You get 3 equals 2x to the 1/2. And then you can divide both sides by 2. So 3/2 equals x to the 1/2. And to get rid of this exponent of a half, I can square both sides. This will be 9/4 equals x. Now, if you remember, when we have fraction exponents, we want to be double sure that we have the correct answer by plugging our answers into the original equation. Because sometimes we get wrong answers when we have fraction exponents in our equation. So I'll just go ahead and do that. I'll start with 1/36. So I'll do 3 times 1 over 36 to the power negative 1 minus 20 times 1 over 36 to the power, and I should put all my things in parentheses, to the power negative 1/2, and then plus 12. So I've got the entire expression written in here, and it should equal 0. Okay, so this is a correct answer. Now let's do the same thing with 9/4. 3 times 9 over 4 to the power negative 1 minus 20 times 9 over 4 to the power negative 1/2. Notice I'm putting all of these fractions, I'm putting them all in parentheses. And then plus 12. Now when I hit enter, I'm hoping to get 0. And I do get 0. So in this case, both answers check out. I get these 2 answers to my equation.